So today, at this moment, we're going to do some exercises, and that is the finding the transfer function C over R with the following differential equation. So basically, we're gonna convert differential equation to the so-called transfer function using Laplace transform, and we're gonna start with this. So the expression is d over dt C of t and 2ct rt. So the t here signifies the time domain. Okay, so we're gonna start with this. So a, right? We're gonna pull a dark pen. So whenever we see a d over dt, d over dt, so we can translate that as s. Then the c will become capital or uppercase, and then the t becomes quantity s, which signifies the Laplace operator, meaning you already transformed. And here in this expression, it's plus, sorry. In this expression, there's a constant. And how do we treat the constant? How do we treat the constant? So we just have to retain the constant 2, and we make the C as before capital, and then we put the S here, and then the R we have to make it big, and then here is the S, right? So what happened now is we try to see the common term. What is common in this expression is this. So we put it outside, and then we're gonna put this in parentheses. So to achieve this, we need to multiply S, and then here we just have to put 2 now. So here CSS now, and then 2CS, okay? And then here is RS. So our objective is C over R, which is G, transfer function, controlled output over reference input. So how do we make this expression into this form? So C should remain at the numerator. So R is in the denominator. So C S. So we have to divide this by itself, right? R is R S, right? It becomes 1, and then we have to cross multiply, right? So here we have to divide also R over S. So CS over RS equals 1. Then this thing here will go here, S plus 2. Okay, so 1 over S plus 2. So that is the answer. Okay, next we go now to this uh, expression, the letter B, d cube over dt cube ct 3d squared c dt squared 7dc over dt 5ct d squared r t d squared plus 4d of d over dt. This is d over dt. Okay, plus 3rt. So how do we manipulate this now? So all the d cube, dt cube, d squared, dt squared, d over dt, no? D squared over dt squared, then um d over dt, right? So d cube, that is a third order, so it becomes s cube. This becomes capital C, and then this becomes S. Okay? Then here, there's a constant. So 3 S squared, then capital C, then we put Laplace operator S. Then here is 7, that is a constant. You just retain the constant. Then d over dt is S. Then this is what? C, and then Laplace operator S. Then 5 is the constant. We make the C capital and then the S. Okay? Then on the other side, so second order, so it means S squared, then capital R becomes S. Then there's a constant here. Then d over dt is S, then R, S. Okay? So we have to identify the common term, and the common term is this, right? Okay, so the common term is this. Now CS, 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 RS, RS. Okay, so we put this outside the term, and then we're gonna factor this out, and then S cubed plus 3S squared plus 7S equals, the common factor is RS, so multiplied by S squared plus 4S. Okay, so the transfer function is C over R, so we put the Laplace operator S, and then it becomes, oh, there's a plus 3, I guess. Okay, plus 3 RT, sorry. Plus 3 RT for this, right? So it becomes 3S plus, I mean, S squared plus 4S plus 3, because the common factor is this. So we put that here, S squared plus 4S plus 3 over S cubed plus 3S squared plus 7S. So now this is the so-called transfer function, using Laplace from these differential equations. So we go now to number, or letter C. Letter C. So how do we do this? We identify this, d squared, dt squared, d over dt, right? And here is d over dt. Okay? So here, d squared over dt squared is S squared, then capital C, a plus operator. Then 6S, then capital C, Laplace operator. Then we retain the 2 as a constant. We make the C capital, case, and then this becomes S. Now we retain the 2 because that is a constant. And d over dt is what? D over dt is S, then R, make it capital, and then S, then plus capital R, then S. Okay, so we were able to do that, and then the next step is to identify the common term. Once we identify, we put that out, common term. In order to get this complete our whole expression, we have to multiply this with S squared, then this one is S6S, then this one is 2, right? CS common. And then here on the right side, we retain the 2. I mean, we factor out R, S. Then we retain the 2s plus 1 in order to get this, right? So finally, the C over R, or the transfer function, is what? 2s plus 1. So we just have to cross multiply. This becomes the denominator, and this one becomes the, uh, I mean, this one becomes the numerator, and the other becomes the denominator, right? C, we retain this, then this goes down, then this goes at the denominator. So 2s plus 1, then this one becomes s squared plus 6s plus 2. Okay, so that's the answer. So we go to the last entry or expression. So this one. So how do we treat this? Look at this, a d cube over d cube, d squared over d over dt, then d cube dt cube squared, then d over dt. So as you can see, there's x and y now. We just have to identify what is output. For example, let no, be the values be defined. So let y becomes output, and x is the input. Now, if that is our case, no, what we could also interchange depending on our desire, right? So here, d cube over dt cube is what? S cube. Then we put the y big, right? Then there's an s, of course. Then plus 3s squared. Then y. Then there's an s. Then plus 5s y s. On the other side, there is d cube over dt cube, which is s cube, then capital X, then s, then plus 4, which is the constant, then d squared over dt squared is s squared, then we put a big X, then what else? Plus 6 is constant, d over dt is s, then we put the big X, plus X. Small x becomes big X. So there are common terms. Now let me grab another color. So the common term, common term. Then there's a common term. Okay. So those are the common terms. So common terms, we put it outside y s. Okay. So we go back to the original color. In order to achieve s cube y s, so we'll multiply with s cube plus 3s squared. We're here already. And then 5sys becomes plus 5s. Okay. Then here is the side of x. So we put it. Okay. So here, if it is the output, so output over input, you put that s. So it becomes what? S cube, 3 squared, right? So here we retain this and then we put this on the denominator, right? So we have this s cube plus 4s squared plus 6s plus 1. Then here becomes the denominator s cubed plus 3s squared plus 5s plus 1. Sorry, this one. I forgot. Okay. 5s plus ys. So plus 1 here. So now this is the answer. Okay, so I think that's it. And these are the answer. Yeah. 1 over s plus 2, s squared plus 4, s plus 3, 3 s cubed, 3 s squared plus 7 s plus 5, then 2s plus 1, s squared plus 6 plus 2. Then this is a bit of invert because we define the y over s, but it's just the same. S cubed plus 3 s squared plus 5s plus 1, s cubed plus 4 s squared plus 6s plus 1. So I think we're done with this. Thank you.